Hi, we're going to spend a little bit of time talking about speed versus mass. Really what this is we're going to look in depth at the kinetic energy of a gas molecule. There are some cool things that we can pull out of it. So from our 5 postulates in the kinetic molecular theory, you'll recall that as you increase kinetic energy, you increase temperature. Or, if you reverse that, decrease of kinetic energy is a decrease in temperature. And I think this is easy to visualize. If I crank up the temperature, those gas molecules are going to start going faster. And if I cool down the temperature, the gas molecules move slower. They have a decrease in kinetic energy. So let's look at kinetic energy. Kinetic energy is 1/2 mv squared. And for those of you who are in AP, you have that on your AP reference. So m is mass, kilograms, and velocity is squared. That's going to be meters per second squared. Now notice these two. They are indirectly related. So if I maintain a kinetic energy but increase the mass, that means that you'd have to have a decrease in the velocity to maintain that kinetic energy. I want you to think about playing marbles. My mom loved playing marbles, she said, when she was little, and she made her best effort for myself and my siblings to play marbles. I was never good at it. But I can still remember this. You have that big steely, you have the big marble, and then you'd have a little tiny marble. And you'd hit both of them, and let's assume you give them both the same amount of energy as you flip them with your thumbs. The large marble, that larger mass, so the larger mass, you applied the same amount of energy, is not going to have the same speed. It's going to roll slower because it's a bigger mass. Now the little tiny marble, usually pretty swirl in it, you apply the same amount of force because it has less mass, it would roll faster. So you can visualize, this is something that you and I can visualize. The bigger the mass, the slower it's going to move, the slower the velocity. Well, that also applies to gases. Now there are 2 really big takeaways from this. And it all goes back to kinetic energy. And I want you to tie this to the kinetic molecular theory. When you read that fifth postulate, that if you increase temperature, you increase kinetic energy, these 2 are proportional. Here are the 2 things I want you to have pop into your mind. This is really important. At a given temperature, the kinetic energy is the same for any gas. So let's say I'm at 25 degrees C. I could have neon, I could have a compound, carbon dioxide, we could have a diatomic molecule, hydrogen gas, we could have any gas, any mass, and it will have the same kinetic energy. This is a favorite question of AP. It's honestly a favorite question of any chemistry teacher, because if a student remembers this, it means that they understand kinetic molecular theory. So super important. A big star in your notes, have like balloons pop out when you read this to help you remember. At any temperature, at a given temperature, any gas has this same kinetic energy. Now what has to be different? The kinetic energy, that has to stay the same, but these gas molecules are going to have different masses. So that means the velocities will be different. So here's your big takeaway. The larger the mass, the slower the velocity, the slower that gas molecule is going to move. So let me give you an example. Let's take our neon, hydrogen, the diatomic gas, and a carbon dioxide. Let's look at their masses, molar masses. Neon is 20.18 grams per mole. Hydrogen is 2.02, and carbon dioxide, 16 times 2 is 32, plus 12 is going to give us 44.01 grams per mole. Okay, largest mass is definitely going to be the carbon dioxide. So that means the carbon dioxide largest mass is going to have the lowest velocity. So if I were to rank these for velocity, so let's do speed, okay, V. And we're going to rank them. We are going to have carbon dioxide will be the slowest. The next largest is neon. And then the smallest is the hydrogen. And so the hydrogen is going to move the fastest. And again, it's justified by this. The smaller that number, if I only have 2.02, and I have to maintain a number here, it means that the velocity is going to go faster. So the justification lies in the formula for kinetic energy. Okay, so two big takeaways. So important. This is a common question. At a given temperature, the kinetic energy is the same for any gas. Yeah, same for any gas. Now, as you increase the mass of a gas, you're going to decrease the velocity. So a big takeaway, the smaller the gas, the faster it goes. The larger the gas, the bigger the mass, the slower it moves, the lower the speed. Okay, nice connection. Good job, you're doing so well. If you haven't watched it, watch the Kinetic Molecular Theory video, and that will help you on this. Have a great day. Thank you.